Welcome back, everyone, to another project, a new project. And if you've read in the description, you'll have a slight idea of what I am going to try to attempt. I will start off by saying that I've mentioned before in one of my other, well, from one of my other projects, the 6 GPU mining rig that I designed, that I am a crypto miner. I have a bunch of graphics cards, and those things produce a lot of heat. And we crypto miners have to fight with the elements, as it were, to keep those things cool. Now, part of the one of the discords that I am in, that where a lot of us discuss ideas and help each other out, specifically for crypto mining. Uh, there's a lot of things that people do to mitigate the amount of heat that keeps getting pushed off, and usually it's installing a bunch of fans. Sometimes, uh, just I mean, we're talking 8-inch, high-powered, moving a lot of cubic feet of air per minute to keep these suckers cool to a reasonable level, and sometimes they're not as cool as they could be, based on the amount of energy being put into them. So, what I would like to do is come up with a scenario, an idea where it may be possible to recapture some of that energy being used. Now, the interesting thing about crypto mining is that they run 24/7 most of the time. Big farms, and that's what they call them when they put a whole bunch of them together. Uh, they call them farms. Let me see if I can pull up a couple of images. Let's see. See what comes on the images here. They should have. There we go. Yeah. I mean, we're talking vast facilities where, and you can see all of this ductwork. I mean, and that's for pulling air and circulating it through to keep these suckers running cooler. The cooler you can make them, the longer their life is. So it increases the amount of return on your investment by extending the life of the card. So, with that in mind, let me check something here. I saw some, let me see, where did I put it? Here we go, in my design. Is this it? Yeah, here we go. Let me get a picture of it. Basically, it's a generator, and each one offers 2400 watts of power, which, let's see, I believe that's, yeah, 120 volt. So you're looking at, what is that, 20 amps? Yeah, right there, 20 amps. Now, the goal would be the rotor speed. In order to produce the full amount, I would have to get this shaft or this motor at 3600 RPM. Now, given the amount of flow, I tried to look up some mathematics and things like that, some tools to see if I could figure out how to convert the amount of energy being pushed when it is known how much cubic feet per minute is being pushed through a given size tube. I haven't found anything like that yet, so I'm hoping to be able to look at that, and then hopefully I can convert that information into a rotor speed depending on the design. The other thing I'm looking at to tie them together, and I try to do this a lot in when I'm working on ideas and stuff. I try to marry existing technologies together in ways that aren't normally thought of. So, with that in mind, if some of these ideas seem a little crazy, that's probably why. So, let's look at. Here we go. This is what I wanted to look at. Let me see if I can bring that to the forefront. Oh, that's pretty good. And it looks like the stream might be acting a little goofy. My apologies, guys. Hello, Hobbyist Miner. Welcome. Thank you for stopping by. And hello, Marcus. Good to see you. Looks like we got a lot of people interested here. I think this is the most people I've had watch at the same time. So anyway, so if you look at actually, let me see if I can bring up another steam turbine generator. Yeah, let me show you this. I want the images. This is so you guys can see where I'm kind of going. Here we go. This is pretty good. Aw, it won't let me blow that up. Maybe there's another picture down through here. That one's pretty good. I don't know if you guys can see this well, but the concept is, for what I'm attempting, I want to bring in air, obviously, warmed air, heated air, and push it through a series of fans, and I think they're called stators, if I remember right, where every other one of these is a fin that's stationary, and what it does is from here it compresses the air for a jet engine. That's what it does, and then there's combustion, and then you get an incredible amount of exhaust and thrust. I'm not looking to do any compression for a steam turbine. It kind of takes the opposite, and you have this volume of high pressure steam usually, and it goes through a series of small discs that are attached to a shaft, and in between those shafts, or sorry, not the shafts, in between each fan is a stationary fin system that increases the velocity of the air by changing the angle in which it goes through the system. Now, since it's heated and gas expands when it's heated, then the next, if you can see in this cutaway where each fan, after a certain amount, the size increases, and that allows, what that does is it allows the shaft to maintain a constant rotationary energy. So from there, what I'm looking to do is grab two of these, and they will be linked by a shaft. This one's a keyway shaft. I'll have to see if I can find or have manufactured a basically a series of basically a turbine, kind of like this, that's normally used for steam, but on a smaller scale, and that would fit basically in a mounting type apparatus for outside or in another part or in a shed or somehow. So that's the concept, that's the idea. Let's see if I can, let's see if there's any other. I wish I could find a bigger picture of that, because that would be really nice. This one's actually pretty good. This is more along the lines of what I was thinking. A significantly scaled down version of this. So what I'll probably do is make the rotors, or make the shaft, design the shaft based on the information that I have for these generators. Now, these guys do sell, and they do sell larger ones, but I wanted to start small. If I have two, uh, if I have enough energy for two of these generators, not motors, sorry, generators, then that would give me 4,800 watts at 120 volts, which is not bad. Especially, I mean, and it's all, especially like if you're using if you use a 9,000, is it 9,000? What's that? What's that? If you have a 240 volt system on a 30 amp, that's 7,200 watts. So if there's a way to take that energy, the waste heat and volume of air coming out of that by way of cooling, because you got to keep your GPUs cool, then you can, if it's possible, and I can get this to run two of these generators for 4,800 watts, I mean, you're looking at more than half your power being recuperated, 67%. Now, I know that's not going to be exactly right, because there's going to be energy losses from friction and things of that nature. So, but that's the concept. So let me go ahead and actually, what I want to do is I want to get ahead and go through and create my new project folder. Please. What did I, is it not working? Why is it not working? There it is. Oh, my computer decided to freak out on me, and it's still doing it. I don't understand. CryptoGenerator. Thank you, Windows. Okay. Alright, well, I can't even. Technology, gotta love it, right? Desktop. Designs. Okay, it's in there. That was weird. I don't know why it was having issues going through. Okay, what's going on? Hello, Anon. Hello, Pure Cane Shot. It looks like I'm getting some lag or something. That's not nice. What the hell's going on here? Yeah, it looks like it's skipping. Are you guys experiencing any errors on your end? Let me know in the chat, in the live chat. Because it keeps saying that it's connecting and disconnecting the chat, and I don't understand why it's doing that. That does not make sense. Alright. Okay, what's going on here? SolidWorks is really not wanting to behave itself. So what I'm going to do is we're going to go through. Let me see if I can get some information off of this motor. Oh, shaft diameter's only, what is that, 7/8? 7/8 of an inch? That's smaller than I thought. I thought it was an inch. That's not bad. Dimensions are 13.3 by 7.6 by 8.1. I'm guessing 13.3 long. And probably the main shaft of the motor is going to be the 7.6. The 8.1 maybe the this little back panel or the housing, maybe mounting. That's very possible. That mounting looks a little kooky because it doesn't look like there's no back support for it. I don't know if I like that idea or not. Anyway, I'll do a blank model of this using a couple of dimensions I'm not going to worry about. And what I'll do is I'll probably contact these guys in the next, hopefully before the next series, and see if I can't get them to send me an actual model of it. That way I can replace it and we can have some stuff that looks really nice. I'll also have to look for some kind of someone that can, or some way I can design this, because this looks extremely complicated. And I don't think I need all of that for the simplistic feature of what I'm going to be doing. I have an idea how I want to do it to make it simpler. This looks just too crazy. Looks like a lot of loss. Let's see. Let's go ahead and do a top plane. Alright. And we're just gonna make, oh, you know what? Oh, come on. I want this. Motor starting 1 horsepower. That's what I'm assuming. How much energy required to, or that part I might have to ask them on what that means. It's possible that a motor of 1 horsepower would require to get this thing up to speed to get it to the right RPM and to be able to produce energy. So let's see here. We've got shaft key waves 1.8, or so okay, this is what I want right there. That's the keyway. So I'm gonna guesstimate the shaft at least 2 inches, maybe 2.5 inches. Doesn't have to be exact. But if I can get the actual model in from this company, then it's very possible that I can design a shaft, an interlinking shaft that has the turbine aspects on it for the power generation side. Alright, so let's go with, let's see here. I'm going to use the 7.6 as the outer diameter. Oh, come on. Be the housing, and I'm going to make this, let's see, it was 13.1, I believe. Let's see here. 13.3, okay. So I'm going to go ahead and extrude this 13.3 minus 2, because I'm going to use 2 inches for the shaft. So 13.3 minus 2 is 11.3. And we'll go ahead and round off. Round that. We'll round them both off just so now it looks like a battery, kind of. Let's see. Okay, that's the top. Put a sketch on there. And need the shaft diameter here. I wonder if it has any drawings on it. It's not showing me any additional information. Sometimes they have like downloadable spec sheet maybe. Oh, I see what they did. Okay. Shaft diameter is 0.874. And we'll extrude that out. Make that 2 inches. I'm not going to put the keyway in. And let's go ahead and do that just for the hell of it. Does not look right. I mean, this is an actual model of it. That's a 3D model. Yeah, so I know they have it. I'll have to see if I can't get a hold of the manufacturer or see if the reseller can get a hold of the manufacturer. Because usually you can do that. Usually you can request things like that. And they'll hook you up. Alright, so that's going to be, oops. Let's go into the CryptoGenerator folder. And I'm going to call it that. Oh, there we go. So the keyway, I mean, that's going to be important when later on when I have to design a shaft that mounts to it, which the keyway will definitely help. And hopefully the way they wired the motor, that the keyway, like if I get 2 of them, and depending on how the motor was designed, if it's like a 3-phase or 2-phase or single phase, that when I line them up, that it'll still produce electricity along the same wave pattern that's synchronized together. Otherwise, I'll probably have to do some research and include some electronics to make sure that it's synchronized, or it just goes in as is. I'll have to look at the specs on that to see if that's an issue, because I didn't see any power information on that. Let's look at that's the installation operator's manual. Sometimes they have that kind of stuff in here. This is like their catch-all for all of their. Yeah, it's a catch-all for several of their models. Okay. That's fine. That's pretty typical. I just wish the spec sheet had a little bit more information on it. Oh, for Pete's sake. Come on, SolidWorks. Quit dying on me here. There we go. Alright, so let me do this. Actually, no. I think what I want to do is start designing the flow system. And what I believe master car, I want. Oh, I want PVC piping though. Let me see if I can find PVC. Nah, I won't need schedule 80. That's crazy. PVC. Don't really care if they're flange connection or not. Tube, round tube, and let's see. They don't have very big ones here. Chemical resistant, $355 for a foot. Yeah, no thanks. I don't need that. Probably have to look at the why is it showing me only chemical resistant? I mean, that's just dumb. Why is it so expensive? It does not make sense. And why are they? You know, MasterCard, I love you, but sometimes you do not make sense. I thought this shit was cheaper. Plus, it is an excellent insulator. This is annoying me. Alright, so let's do PVC standard. Whoops. Standard sizes. Because I think I want at least, yeah, here we go. 10-inch. Alright, so the other thing I want to look for is 10-inch going to be big enough? Should be. Let's look at that. Yeah, we'll start out with 10-inch. And then we'll go from there. Let's see. 10-inch PVC T. Whoops. I'll just make them. Simply shouldn't even be up. I needed dimensions for it though. 10-inch PVC-T. Goodness. Why am I having such a hard time? Where's the fittings? Here we go. They only have 6-inch? Come on. Really? 6 inches all they got? This is nuts. Alright. Dimensions. Oh my goodness. I don't want a 4-way. I just want a T. Oh, it's a T. Well, that's pretty interesting. The slip T. That's not what I need though. Here we go. Two-inch. Oh my God, guys. Alright, well, we're just going to have to go with this information here and then make one. Alright, so OD is 10.75. And the wall thickness for these is 0.365. Alright, I'm going to slide this over to the other side of the screen so I can keep an eye on this and look at it while I'm designing. Yeah, we'll do top plane. This is going to be construction geometry. So I can map out the inside of this bad boy. Alright, 10.75. For the T, that'll be the inside diameter. It'll probably be slightly over that. We'll do 10.8. Slip fit. So you can put your PVC, put it in place. Alright, now I want to offset that, the thickness of the pipe. 0.365. And we're going to extrude that. Let's see, 10. So 18 inches. I'm going to do it mid-plane. Whoops. There we go. And then, no, that's the top plane, front plane. Then on the right plane, we're going to draw the same thing. 10.8. This is going to be like that. Offset the same amount. And then we're going to extrude that. Gonna extrude that. I don't need it to be 18 inches. We'll go 9 inches on that. Okay. And then what we can do is I can show this. Oh, nope. I need to. Oh, come on. I'm going to create a sketch. And we're going to use that to create my through. Extrude cut. Through all. Done. And then I can hide this now. And we're going to show that one. I'm going to create a sketch on that plane. And we're going to do the same thing, but not through all. What I'll do is, I can either do, I think I can do up to next. Yeah, and it'll just carve it out. Kind of nice that way. Yep. And we'll hide that. Now, I don't know if this is going to be PVC. I was just, for mocking up a model and doing some, yeah, that will look fine. To do some like testing and some conceptualizing. That might work. I'm going to call this 10-inch air splitter. Now what I would like to do, I don't know if that's possible. Oh, it's thinking about it. Okay, there we go. It might be possible to split the air coming in. See, what I'd like for it to do is to be like this. Mounted like this, and then the shaft and stuff is on the internal. 10 inch, is that going to be enough? If I have a 10 inch, basically it would be a 10, well, let's see, how does that work? If I have a 10-inch fan, well, it won't necessarily be 10, but yeah, 10-inch fan, and it's capturing energy and spinning, then the further in you go, it's still going to spin the same amount. So it doesn't necessarily itself have a gearing reduction. I would have to go from the small size to larger in order to get somewhat of a gearing reduction type thing going. Let me think. I'm gonna have to look some of that stuff up. It's been a while. I'm a little bit rusty with it. So let's see if I can create an internal piece that actually splits the incoming air, diverts it both ways so it doesn't really hit, stop, and then fill. I think that would be much better. So how would I do that? can I do that? It would almost have to be like a slipped in feature. But then that would reduce the amount of airflow through this cavity. Let's try something here. Let's create a new part. And I'm going to do something crazy. Maybe. Could be a two-piece with a hole in the middle. Let me see here. Yeah, chat is acting really funny. I don't know what's going on with it, guys. I apologize. Must be something on YouTube's end. Kind of crazy. Alright, let's think about this. I want to do... I can see it in my mind how I want it to do. I'm just trying to think of what I need to do in here. Be a scooped, like an elbow back to back that's shaved. Alright, let's get out of that. And I think what we're going to do here No. I need to do a 3D sketch. I want it to be up. Why is it not locking in? There we go. Made that 18 inches. It's 10-inch diameter. I may have to make that bigger. Ooh, I know how I can do it. Okay. Yep. This. Let's figure out. Let's start with 6 for now. And we'll make that 6 as well, just for now. And then I need a fillet. 3-inch radius. I think that's gonna... No, that should be fine. Alright, now... I pick both of these and I use the sweep feature. Yep. Why? Oh, because that radius or the length is not enough. Alright, so I've got to figure this out here. I need 3. Let's go 9 then. There we go. Maybe that'll work. Let's see here. Why is it? Okay. Maybe this is not going to work. I'm gonna need at least, yeah, 12 inches on that. Same here. It's got to have enough room to do that curl, to swoop in. I can make what it is and then cut it down after the fact, I believe. We'll have to see here. Seriously? Yeah, should be showing a preview, but obviously it's not working. Okay, what am I doing wrong here? Okay, let's just go stupid. That did 180 something, didn't it? Yeah, it did. 118. Or is it the radius? Is that too much or no? Still not. Okay, this is pissing me off. I don't know why it's doing that. Ah. Alright. I'm going to take that and mirror. Oh my goodness. Okay, okay, okay. Come on. Alright, we're going to make a plane based off the front. That'll be, what, 24 inches then? Other way. Oh. Yeah, that should be right. 18 inches. And we're going to mirror that. I like full preview. Okay. And we want to do What's the idea on that? Where did the other one go? Somehow I've lost it. Okay. Well, that's fun. Oh. Yeah. Oh, yeah. I'm going to extrude that up to offset from... Can I pick the plane as the surface? Yes, I can. It's not actually what I want it to do, though. I want it to follow that surface. Well, that's not going to work. Let me do this. I want that. There we go. That's what I want. Okay, thank you. Section that out. And I want to have a little bit of thickness there, but I don't need all that height. Let's see, how can I do this? Hey, Paladin. Welcome, good sir. And hello to Anon as well. I didn't get to say hi earlier. I just saw the hello. There's a bunch of people on a few minutes ago, and then everybody disappeared. Alright, you know what? Let's get rid of this. And I will hold on to that because I think I have an idea here. Let's sketch on this plane. Go tangent to there. And go ahead, just then what I'm going to do is extrude or cut that out. All then let's do this, and actually, you know what? That's not what I want to do. I messed up. let me do this first. I can keep that sketch, and I'm going to go do this, and we're going to hollow this. That's what I should have done before. Okay, now I'm on the right path. 10. Then we'll close that out, and I'm going to utilize the same 3D sketch and do. There's sweep cut. That's what I want. Yes, that's what I want. Boom. There we go. Basically, it's an elbow, but it's not quite an elbow. Now, I want to do that. Make that plane, that sketch. And I'm going to cut that out. Alright, now we're in business. This is what I'm looking for. What is this top plane? Yeah, still connecting and disconnecting. I don't understand why it keeps doing that. I just don't get it. Alright. I need a line. Here to here. Wait, what? Okay, this is not what I meant to do. Why? What is this doing? Get rid of that. I want this feature. I want that plane. I want that. There we go. Now let's do an extrusion. And yeah, we can just do it. 0.125, I think is good enough. Zero thickness geometry, where? Can I go that way with it? Okay. That was weird. Now I want to take all of this and mirror it. Oh, not that. Mirror that about there. Now that should what? Why did it do that? It mirrored and then deleted the other one? That's not what it's supposed to do. I'm confused. Wow. This is so weird. It's really not letting me do it. Oh, merge result. Okay, wait, that wasn't. Oh, I know. Okay, okay. We'll taper it out. There we go. That's why, because it was. Yeah. Yeah, that'll be enough. No. Okay. It really should not be this difficult. So I offset it 0.05 just so I can get it out and around. Now, can I extrude that, please? Thank you. Oh, why didn't it merge? God damn this thing. It's really dumb. Oh, that's why. I can fix that later. That's fine. I'm not really all that worried about it. Now, let's mirror this freaking stuff. Oops. Mirror. Mirror plane. There we go. But, what? Why is it doing this? This is really fucking stupid. I don't understand this. It should just flip it over and be done. There's no reason why it should be cutting this shit apart. That's just fucking stupid. Alright, let's get rid of some material here. It's pissing me off. Okay, that doesn't help. Up to next. That's what I What is this thing doing? Jesus Christ. This inches. Jeez. Alright, there we go. That's all I wanted to do. Let's see. Thickness there. Wait, what? That should be. God, what the hell? Oh, what's going on here? Oh. Seriously? What? Why isn't it mirroring it? It shows it's mirroring it right there, but then it's getting rid of that. Oh, wow. This is very aggravating. I don't understand what it's doing. This does not make any sense at all. That's what it should have done. Just no, that's what the fuck is going on here? This is aggravating. I don't understand why it keeps doing this shit. It's just... Alright, it's good. It makes no sense to me whatsoever. Now it's closed here? What the fuck? Okay, I can't have anything the way I want. What in the ever-loving fuck is going on? Do it this way. Alright, what am I doing here? Let's see here. What can I do? That's weird. Let's see what it does. That's so funky. Why for does it do this? Can I do this? Yeah, I don't understand why this thing is being so difficult. It makes no sense whatsoever. What does that do for me? Nothing. Of course. Why would it? Let's try this. Just try something different here. Because everything, nothing else is working, so why not? See, that's not helpful. Okay, that works so far. Why it had to be so freaking difficult, but okay. Sketch on there. Let's see, can I do a line from here to right there? See if I can do the what? Huh? Okay, why? Seriously? Does really not know to grab? Fuck me. Damn thing is acting so stupid. Mid-plane. Want that to go up to next. Uh, 45 and 0.12. Actually, I don't want 45. I think I want to do, let's do 15 degrees. What the fuck? What else? Oh my god. Okay. Oh my goodness. Don't like that. Really don't like that. Oh boy. Yeah. Sure. Let's see what this does. Yeah, that looks okay. Alright. Now we'll hack this thing up. Because I don't need much of it. Just need a little piece. Oh, this is no go because I have to do all that down once I cut it anyway. So yeah, that's no go. That was dumb. Wait, what? Someone give me a half? There we go. So dumb. Extruded cut. 12 inches. Yes. And we'll do the same thing over here. Let's see what that looks like. Yeah, I think that's okay. And I want yeah, it's a little thick. Let's go 0.125. This will be a machine piece, because I would have to redesign it for plastic extrusion. You know what? Yep, we're going to do it that way. Okay, that's nice. And that's what I want. Let's call this the 10-inch hello. Oh, thank you. You did it. Okay. Oh, that was one other thing I forgot. I've got to have let's do this. And yeah, it has to be on that center. Because the shaft has to go all the way through. The shaft diameter is 0.874, which is roughly 7/8. And I'll probably have to have a decent collar if I'm running a shaft of any length. So we'll go 1.25 inches on the shaft connector, connecting rod, and I'll do 1.5 inches on that for now. We'll start off with 1.5 inches. Oh, really? Okay. All right. Now what I want to look at. All right, let's look at this. Let's go ahead and make make assembly from part. Oh, that's not how I want it in there. Let's see, how can I do this? I want that to be normal 2. Oh my goodness. Yeah, this, okay. Oh my good golly. I want this to be my top. So click the standard view like the site. There it is, top. Yes, thank you. Goodbye. So now that's what I want. Been a long time since I've done that, so I had actually forgotten how to do that. Alright, now I want to add in diverter. And I forgot. Is that right? 10.8 and this is 10.75. Okay, so this to this, centric, and that's not going to work. That has to be shorter than that. I'll have to figure this out. Basically, I need to marry these two together in concept. That's what I need to do. And I don't know that that's even possible from a manufacturing standpoint. That would be hella expensive to mill out from a solid block of aluminum, and even, geez. I'd probably have to look and see if there's anything like this on the market, because this isn't something you could actually mold. It would have to be milled. I'd have to significantly do a lot of manipulation on that to see if I can do that. But for now, it is what it is, and I'm leaving it like that. We're gonna call this intake subassembly, and we'll wait 20 minutes. Okay, there it goes. So I want to look at something here. Oh, I see. So honestly, that needs to be cut down basically to this point. Then it could slide in and out. Well, I mean, I'd have to get an actual PVC-T in to make sure that that works. But that's pretty cool, honestly. We'd have to slide in and fasten somehow. Well, for now, it is what it is. I am actually just going to leave it like this because that looks pretty cool. Now, so let's assume, let's see here. I wonder if I can get a volumetric measurement on this. No, that's not what I want. Right. I'm not exactly sure what. Let me see here. Let's see. What is this? Mark that up. No, mass properties. It's got 155.8 cubic inches of volume. What is this? Okay, I don't have any there. What? Create center of mass feature, and that doesn't. So I'm taking it and splitting it. That's almost what it needs to be there. All right, I think this is a good moment to take a few minutes to stretch the legs. And we'll be right back after these messages. Actually, after the break, I don't have any messages. It's not an easy one. No, it's not. Left with your messages. All right, and back. Okay. Let's take this and, oops, make an assembly from this and tie it to the main. Aw, that's not what I wanted it to do. Alright, so we're going to have to do this again. We'll go here. And then, let's see, what was that? Update standard views. Click the view. Top, yes. Boom, done. Yes, I like that. Okay. This will be the crypto. That way I can get my motor in there and kind of get some ideas of where I want to space some stuff here. Whoops, that's not what I wanted to do. Oh, stop. Let's insert this. Make that concentric with that. And pull that. You know, let's see. Let's go from the front face of this to the top plane of that. And we'll do, God, let's try, let's try 12 inches. That's not going to be enough. Do 24. And we're going to do the same thing on this side. Okay, I think we're going to have to change the way this design is because, or at least eventually, because I don't have any way to do some assembly and disassembly. Right now it's assuming that everything's together, but I can do that a little further down the line. That's amazing how small those are compared to the amount of ductwork I want to work on, or that I want to do. So now I need an intermittent shaft between the two. Let's see, from here to here should be, I forget now, 48 inches. So we'll do 46 on the shaft. I need a new part. And we'll just do that 1.25 inches. And we'll extrude that mid-plane to 46 inches. And then it'll have to have the keyway cut out. What's that shaft diameter again? 0.874. So I'll make this 0.875 for now. Oops, there we go. And we'll do that. I may have to double check this. It's 48, so I got an inch on each end. And I think I made those 2 inches. So if I do 1 inch in, and of course we'll have to chamfer that. Oh, there we go. That's better. Oops. Inch in. And then I'll chamfer that as well. What would be cool as hell is if I could have a, on the picture of that, if you look at the shaft, it does have a threaded insert within the keyway. But I don't have that information, and it may not be threaded, it may just be oh yeah, the keyway, and then there's a whatever gear or whatever you put on there, it threads in and holds it in place. So that's probably a threaded, that shaft is probably threaded. Would have to take the keyway out though, and I don't like that idea. If I was to make this piece to mate with that exactly, there might be a way to do that. Of course, I'd probably have to split the rod, or the shaft rather. We'll have to worry about that later. Because I think the keyway would come out, but then you'd have to get it back in, and there's not really a way to do that. The other option would be to put a couple of set screws in there. But that keyway would have to match. Call this main shaft for now. Come on, SolidWorks. Thank you. Where is the... so let's go like this for now. Alright, then I need a shroud. I really don't think this piece is necessary if I have this manufactured. But we can take it out later. I'm not worried about it right now. Alright. Airflow comes in, gets diverted, rotates. And then we have to have it exhaust. The question will be volume, temp coming out, yeah, that's actually pretty cool so far. Now I need a housing that mates with everything. Let me think here. I still got to figure out how to design the turbine fans. I mean, we'll probably have to do a do something on a smaller scale for testing, just to see if it's even conceivable, if it's actually going to work. So let's see, if I'm 10 inches here and in 2 feet, what am I expecting? I'm going to change this. That's better. I like that a lot better. It lets me see this the way it's supposed to be seen, I think. Now, the only other thing that, I mean, doing something like this would force users to utilize a 10-inch ductwork. And I am pretty sure that your pressure changes when pressure decreases when volume increases. So if there is X amount of air flowing through a certain size diameter pipe, once you increase the amount of volume that that air can occupy, then it decreases its pressure. So it's not as forceful. But, and I'm pretty sure there's a formula for that, and it's probably related to Ohm's law, but it's pressure law. Uh, Pressure law formula? Constant volume, the pressure is directly proportional to the absolute temperature. What about the volume? The temperature and the amount of gas remain unchanged within a closed system. As volume decreases, pressure of the gas increases. Oh wait, there's a. That's what I was thinking. Volume if the temperature and amount of gas remain unchanged in a closed system. Pressure is inversely proportional to volume, or pressure multiplied by volume equals some constant. Alright, that's pretty cool. Volume decreases, pressure increases. Yeah, that makes sense. So what I said before, if you're going from a small to a big, then that pressure is going to decrease. I mean, but that's also in a closed system as well. I would like this to be designed in a closed loop system, but that's going to add a significant amount of complexity and cost. I mean, it's possible I could do that. That way it's circulating the same air that, going through the system is just cooling and heating. But this is designed so that if anybody, they can just basically plop this in, hook it up to their exhaust, and it'll generate electricity depending on the amount of volume at any given pressure. So, and there's got to be a way to measure that. I would like to do that. I would love to experiment with this, because this would be a fun and fascinating thing where I could maybe grab a couple of car alternators or something just to run some tests, just to see if it can get one of these inline. Let's see. Gosh, what is the name of that? 8-inch inline duct fan. Yeah, there they are. It does. What was this? What was the amount of? I thought it gave a. Oh, technical specs. That's what I want. Oh my goodness. 807 cubic feet per minute. That's quite a bit. So, cubic feet per minute, 807. And I'm assuming that's on its highest setting. Kind of duh. Static pressure, 746 pascals. Oh no, that's... Is there a... Whoops. Is that right? Let me make sure that's 746. That's roughly 0.1. 0.1 pound force per square inch. Atmospheric pressure is 14.7. That's not a lot of pressure. If we decrease that, if 8 inches is 746, then 4 inches that would be double. That's still not a lot. That's not a lot of pressure, honestly. This may not work at all. Because I've got a lot of weight here to move around. Now, this could be aluminum. And if the bearings are right and all that stuff, I can minimize a lot of friction. This will be an interesting experience and experiment. Oops, I keep doing that. Okay. But 807 cubic feet per minute. 807 cubic feet per minute. And if we assume an 8-foot ceiling, that's basically the area of this, basically the size of a standard kitchen, a 10 by 10, 10 foot by 10 foot room by 8 feet tall. That's basically that much area, volume of air going through this thing every minute. That's pretty interesting. I think they have a 10-inch one too. I wonder what the 10-inch one is. Where are they at? Inline duct fans. I don't need all that nonsense. 4, 6, 10. Oh, they even have a 12. That would move some air. Huh. Let's look at the technical specs on that. That's crazy. So, wow. 12 inches is 1600, so roughly double. So 2 kitchens. 2 volume of air in a kitchen per minute. And the static pressure is 818 pascals. That's a slight improvement, but man, that's huge. That would be like my whole basement. Well, now, well, about half of my basement getting circulated every minute. Actually, a little more because my basement is a little short. It's not quite 8 feet tall. like 7.6 or something like that. I don't remember. But that's pretty good information to know. Okay, so from here, I'm not heating the gas. It's already heated as it comes in. So as it loses energy, it's probably going to cool and condense. So I would probably have to make the fans go smaller. Let me save this. I think what I'm going to have to do is do a little bit of research on this to see how the best way to design the next series system on this. And I'll probably try and figure out how to redo this to where I can make it make the assembly make sense. But that I may have to wait a little further down the road once I get the initial concept down. Yeah, I don't think I'm gonna need this, but I can get back some of the bring back some of the information I did on that one and make that as my standard piece, and then connect these back up. Because assembly would be kind of crazy. You have to detach one, or detach the motors, dismount one, slide the shaft out, and then lift that out of place. Actually, that's not bad. It's really simple. No, I take that back. Simply because of the fans that'll be on here. So this may have to be a termination point. Where in the So it's a single shaft that goes up to a point but doesn't connect or go all the way through and connect. It's actually separate. Yeah, I may have to redesign this a little bit from a assembly and disassembly point of view. I'll think about that kind of stuff. I'm going to have to do a little bit more research, I think, and actually see if I can find some turbofans. Or maybe even, because I know they make miniature, like, jet engines for model cars that have actual turbines in them and craziness. Not model cars, model airplanes or jets. So maybe that's the ticket. But those are based on pulling compressed air, pulling in air, compressing it, and then igniting it. So, I mean, it won't be the same idea unless I put, spark plugs on the end of it and ignite it. But I don't think, because then I would have to have a fuel as well, which that would be insane. But that would be way too expensive. Nobody's gonna pay for that. Anyway, I think I'm gonna wrap this up tonight from here, and we'll come back next week, and I'll see if I can't have some of this other stuff ironed out so that I can get started, and I'll contact companies and see if I can't get some models in, and we'll go from there. Thanks to everybody that stopped by. I appreciate it, and I look forward to keep doing this project in the next several weeks. So this will be fun. I will catch everyone next week. Thank you so much. I'll see you later.